Okay, number one, it says let a of x equal whatever it is. What is the local max? How do I find a local max or min? Okay, what are you looking for in the derivative? For local max, you're looking for when the derivative changes from positive to negative. For a local min, you're looking for when the derivative changes from negative to positive. So, a prime of x, what would the derivative be there? What rule? Chain rule and product rule. So what would we have? 2 plus 2 times x minus 3 to the first times 1, then times the first thing. So times 2x. And then what do we do with this? Find the zeros, but it'd probably be a good idea to factor first. Let me simplify it a little bit. 2x minus 3 squared plus 4x times x minus 3. And you can distribute all that and factor it that way once you're all said and done, but it's easier this way. What's the common factor? 2 times x minus 3. What's left over on this one? X minus 3. What's left over on this one? Plus 2x. So we can simplify that now. So 2 times x minus 3 times 3x minus 3. We can factor some more. So we can factor a 3 out of that. So it would say what? 6 times x minus 3 times x minus 3. Okay, so that is our factored form of the derivative. Now what? You're looking for all critical points, right? Is there any endpoints? No. Is there any points where the derivative does not exist? No. So we're only looking at when the derivative equals 0. And that occurs when x equals 3 and 1. So we set up our number line 1 and 3. That's when the derivative is 0, so a prime. Good number? 0 is a good number there, so we're going to get positive times a negative, so positive. 2, so positive, positive, so negative. And then 4, so positive, positive, positive. So what does this tell me? We have a local max when x equals 1. And the justification is since a prime changes from positive to negative. And we have a local min, yes, when x equals 3. I was just going to get to that. It says, what is the local max and the local min? So this is where they occur. And a lot of you on your tests didn't pay attention to the question. The last one in particular, it said, for what x values are there a point of inflection? And you guys gave me a coordinate. Not all of you, but some of you, right? Oh, it must have been you, right? So what do I do to find my local max? Plug it into the original. So we would say a of 1 is what? 2 times 1 times 1 minus 3 squared. So 8, is that what you said? Okay. And then a of 3 would be 2 times 3 times 3 minus 3 squared, which is 0. So our local max is, well, it's the high point, so it's just 8. And the local min is 0. Okay? Any questions? Number 2. That one's easy. What do you do? Quotient rule, chain rule, trig, exponent. So what's the derivative of the top? 2 sine of x times cosine of x times the bottom minus derivative of the bottom e to the x times sine squared x all over e to the x squared. So simplify it just a little bit. What does the bottom become? E to the 2x. What can I factor out of the top? e to the x and sine of x. So left over would be 2 cosine of x minus sine of x all over e to the 2x, you could argue, and then these reduce. So you have sine of x times 2 cosine of x minus sine of x over e to the x. You guys okay with that? Simple enough, maybe? So this unit, I will tell you right up front, it's not the easiest, but it is the most rewarding. What does that mean? No, the most rewarding is when I have the highest grade on my test. Not true. Okay. What's cool about this unit, and we're going to just do an activity to kind of explore what's happening here, is that we're going to apply calculus to real life. We've done it a little bit, right? We've found we do it all the time. Well, not all the time, because this isn't really applied to real life. But has any of you ever wondered why when you get the package from Amazon, well, Amazon's a little bit different story, but why certain things are packaged the way they are? To make it cheaper. But why would packaging it a certain way make it cheaper? Smaller material. So let's say you had a box. What concept is dealing with the material for the box mathematically? If we're talking about the material of the box, that's not the amount of space inside. That's the surface area, right? Now, the surface area has to be able to fit what's inside, which is the volume, right? So there's a relationship between volume and surface area. So the idea of this is, in one case, in one context, is can we take find the least amount of material to make a box or anything to fit the most amount of material inside. One great example is the soda can. 12-ounce soda can, right? Why is every Pepsi can, Coke can, 7-Up can, every 12-ounce can exactly the same size? You would think as a company you would want to be unique and change the size so you have something different. Why? It's because they're cheapskates. But why? What determined? There it is. They want to use the least amount of aluminum to fit the amount of soda in the can. And when you're talking about the least amount of something, what are you finding in calculus? A minimum. Bing. Okay. So, it's good stuff, yeah? All right. So I'm going to pass out just an activity that kind of warm you up to this idea a little bit. It's dealing with a dog fence. All right. So you can buddy up with somebody, but I'll tell you that this unit now, we've been talking about your problems with algebra, and that's why the calculus is difficult in a lot of ways, right? Well, guess what? This is going to reveal how good you are in geometry. So I'm going to give you time on this, okay? But I want you to kind of follow through with this, and this hopefully reveals the relationship of calculus to geometry. You already kind of see the relationship of calculus to algebra, okay? But go ahead and work through this. Do the best you can on it. And then when you're done with it, when you think you got it, do the second part. A rectangle has a perimeter of 8 meters. What is the largest area that could fit in the rectangle? Okay, so quick story. I don't know if I said this, but these guys are all negotiating, bringing fencing in to actually represent this. It was my very first year of teaching. I did a project on, building a house, geometry, blah, blah, blah. So they had to bring in samples of like the carpet they were going to use in their house. And so I said, go to Home Depot or go to Lowe's. They'll give you them for free. Say you're doing a math. So most kids did this. This girl came in with this raggedy piece of carpet. I said, where did you get that? She goes, so I have a cat litter box, and I couldn't get to Home Depot, so I took the litter box and I cut a piece of carpet out from underneath it from the floor, and so my parents don't know. All that for your geometry grade, huh? That's pretty bad. I guess, you know. Now what do you do? I mean, all right. Okay. I don't know. I think I had to give it to her just for that. Okay, but looking at this, so you have the wall, and then you have these sides A, and B. Now you guys did the data table and you created the graph. Maybe your graph is accurate, maybe it's not. What did you observe to be the largest possible area? But what was the largest area? It was 200, okay? So we said that we had 40 feet of fencing. So we created an equation that would say 2A plus B equals 40, and that's why when you picked an A, you can find B, right? Okay? But what is it we were trying to find the maximum of? The what? The area. We were trying to find the biggest possible area that we can find, right? So this doesn't really matter. I mean, it will, but we weren't trying to optimize this. We were trying to optimize area. So what's the equation for area of a rectangle? In this case, it's A times B because we have that, right? Are we okay with that? But on your paper, it said we want the area function in respect to just A. Right now, the area function is in respect to A and B. So we have to get rid of the B. What are we going to do? Yeah, just ignore it, right? Yeah, let's get B by itself here. So we'll subtract 2A. And we end up with B equals 40 minus 2A. And then what do we do with that? Plug it in. So it's big A equals A times 40 minus 2A. Now, can I simplify this a little bit? Yeah, that's probably a good idea. And notice, now we have the area in respect to just A, right? So this actually is a function now. Big A in respect to A is equal to 40A minus 2A squared. Are you guys okay with that? What kind of shape is that? It's a parabola. What kind of parabola? An upside down parabola. And then you looked at your graph and you realized, oh, it looks like an upside down parabola. Right? Well, maybe not all of yours look like an upside down parabola. That looks like, never mind. I was going to say it looks like the stock market, but you know. Okay. So now the next part of this said we want to, what? We want to determine the maximum area. Well, how do you find the maximum of a function? You've got to take the derivative, right? Just like we did on the warm-up. So now, before we take the derivative, what is the function? What's the name of the function? No. It's the area, big A, right? What is the variable of this function? Little a, right? So when you take the derivative, you're doing it right. So what's the derivative of area? A prime of A, little a. What's the derivative of 40A? 40. What's the derivative of that? Minus 4A. You guys okay with that? Now, remember, in order to find relative extrema or absolute extrema, you have to consider what? All possible critical points, right? What are the critical points? Endpoints, when the derivative doesn't exist, and when the derivative is 0. Well, what were the endpoints of A? What was the biggest value of A and the smallest value of A that makes this function work? A couldn't be anything smaller than 0. That wouldn't make sense. And it couldn't be anything bigger than 20. Why couldn't it be anything bigger than 20? Because if that was 20 and that's 20, that would make this length 0. And so if these were bigger than that, that would make this negative, and that doesn't make sense. So we would say our critical points, the first one is 0. Second one's 20. And then what else do I have to do? We got to set this equal to 0. And solve. So you got 4A equals 40, so A is 10. There's our other critical point. And then what do I do with my critical points to determine extrema? Set up the number line. So endpoint is 0 and 20. and that one in the middle, so that's when the derivative is 0. That's at an endpoint. That's at an endpoint. So this is A prime. Pick a number. What's a good number? 5. So 40 minus 20, that'd be positive. 15 maybe? Negative. So since A prime is positive in this domain, that means the function is, the area is increasing, right? Yeah. And then since the derivative is negative in this domain, that means the derivative is, or the function is decreasing. Oh, that would make 10a maximum. What's that make? 0. A minimum. And what's that make? 20. And if you look at your parabola, does that make sense? The highest point was at 10 and the lowest points were at 0 and 20, right? So we can say the absolute maximum area occurs when A equals 10, right? You guys okay with that? And you could write out the justification and all that. Since A prime is strictly positive from 0 to 10, and A prime is strictly negative from 10 to 20, that makes when A is 10 an absolute max. Was the question asking for the value of A, or was it asking for the absolute maximum area? It was asking for the absolute maximum area, so what do I have to do with this? Plug it in. So we're going to plug it into this one right here, because it's in terms of A, right? You could plug 10 in here and find B, and then take those and multiply them, that's fine. But A of 10 is equal to 40 times 10 minus 2 times 10 squared, which is 400 minus what? 200, which is 200. What's the units on this? Was it feet? So feet squared. What do you mean?
You're not making rectangles.
What would you like to make?
Let's make like a circle.
A circle?
Yeah.
Well, a circle is going to be locked in. If you've got 40 feet of fencing to go around a circle, you can't change the area, right?
What about a semicircle?
A pentagon, sure. What kind of pentagon, though? If it's a regular pentagon, they're all the same, so you can have the same issue. Do you know the area of a pentagon?
No. I do.
Okay, so what'd you say? Maybe a semicircle, yeah, because, well,
There's a wall. And then
those things are locked in. A triangle might make more sense, like a right triangle or something like that.
yeah, like
But the idea is, I guess people can make circular area boundaries, but whatever. Okay. All right.
what if you finding out like how much of some there's like
All right. Can you guys flip over the page? Okay. You have a second problem there. It says a rectangle has a perimeter of 8 meters. A rectangle has a perimeter of 8 meters. What is the largest area that could fit in the rectangle? So you have to create an equation that gives you what? A perimeter. And you also have to give me an equation that gives you an area. Okay? Draw a picture first. Okay. Just so we're not out of time, okay? The process that I'm giving you right now is the process that you need to follow when you're talking about optimization. Because a lot of times when you're creating an equation in geometry, you have multiple variables, right? Okay? So we can't deal with something that has multiple variables. We don't know how to take the derivative of that because the variable, if we're taking the derivative in respect to A, and then I have a variable that's B, that doesn't make sense. Okay? So it says that we have a rectangle, right? So here's a rectangle. First thing you want to do is draw a picture. We'll talk about more of this tomorrow. But let's call this L and W, just to change it up a little bit. Okay? What would the equation be for perimeter? Perimeter is 2L's plus 2W's. Now this is different than the previous problem because we don't have one side taken up by the wall, right? What does it tell you about the perimeter? It's 8. Can I simplify this equation in any way? Divide by 2 so you get 4 equals L plus W, right? You guys okay with this? Okay. The big question here, though, it says, what is the largest area? So this equation doesn't give me area, so I can't find the largest area using this equation. I've got to have another equation that gives me area. So what's the equation for area? L times W? But if I want to optimize that, if I want the largest area, what am I going to have to do with that ultimately? Take the derivative, right? Can't take the derivative with two variables. So I've got to get rid of one of them. Which one do you want to get rid of?
W. No, L.
It doesn't matter, right? Let's get rid of W just for the heck of it. So we're going to get 4 minus L equals W, right? So what is this equation going to say then? L times 4 minus L. So then area in respect to L is equal to 4L minus L squared. So again, another parabola. Now what? Derivative. So A prime of L, where A is the function and L is the variable. Derivative is 4 minus 2L. What is the maximum value? Sorry, what is the least value of L? What is the smallest L value? Okay, critical points are when L equals 0. What is the biggest value of L? Why 2? If the perimeter is 8, then L would have to be, the biggest it could be is 4. Because then you'd have 4 plus 4 is 8, and that would make the W's 0, right? So 4 is the biggest. And then how are we going to find out any other critical points? Set it equal to 0. So we get 2L equals 4, so L equals 2. So we got another critical point there. Set up our number line. 0, 4, 2. 0, endpoints. Endpoints. And that's for what? Area prime? So there's not many numbers you can pick. 1's good, so what do you get? Positive. 3's good, so you get negative. So almost the same problem, right? Yeah? But this one's unique and this one's interesting. Where's the maximum? 2. So we would say the max area is when L equals 2, right? You okay with that? It's not a what? What would it be? Oh, we got to go back to geometry, I think. Oh, okay. Anyways, the max area is when L equals 2 because A prime is changing from positive to negative, right? Actually, that justification is only for what kind of extrema? If I strictly say A prime is changing from positive to negative, I'm saying that it's a relative max. I want the absolute max. So what's the justification for absolute max? Well, yeah, but remember, you can't say, since this is the only maximum, like this is the only relative max, right? It's not the absolute max, though, because there isn't one, because this point's higher, right? Because this, right here, because A prime is strictly positive from 0 to 2, and A prime is strictly negative from 2 to 4. That's the justification for absolute, okay? It doesn't matter. You guys understand that it's absolute max, right? So what is the absolute maximum area? Well, let's take a step back here. If the perimeter is 8, we would say 8 equals 2 times 2 plus 2W. So that's 8 equals 4 plus 2W, which makes W what? 2. So then the area would be, the maximum area is 2 times 2, which is 4. And so you guys pointed out, wait a minute, that's not a rectangle, it's a square. 2 and 2, the area would be 4. Is a square a rectangle? No. Yes, it is. Right? It's like saying A golden retriever is not a dog because it's a golden retriever. Okay, so think of that a little bit. No, the definition of a rectangle is that you have a quadrilateral, right, with 4 right angles, basically. That's what a rectangle is. So is a square a quadrilateral? Does it have 4 right angles? Then a square is a rectangle. Now this is interesting, and we can express this in general, that the maximum area of any rectangle always occurs when you have a square and nothing else. That's why a square is so unique.
I have like a serious question. Can we like jump back? How did you get from 80 from 12? There you go. Oh, how I feel like your head is right on top.
Oh, right here? Okay.
80 equals 2L plus W to 4 equals L plus W. How did you?
I divided both sides by 2.
Okay. Right. Children, I asked you and you said you didn't know.
Are we okay with that? All right. So I guess a quick recap. This is, I guess, a different way of looking at it. I used A and B, right? But basically the same thing. What did I put it in terms of? I put it in terms of A, just like the previous problem. Okay. So it's the same problem, same answer. Okay. I will have a list for you guys for your homework for tomorrow. I will do my best to post it. Yes. I gotta figure that out. Yeah, try and do the homework tonight. Yes.